Good afternoon everyone. Welcome to my lecture on quantum computing with Qiskit. Today we're going to talk about the most basic quantum algorithm, which is known as Deutsch algorithm. I am Rifatul Islam Himel. I am quantum computing and Qiskit enthusiast. I love to learn about quantum computing and Qiskit and want to share my understanding. Today we're going to cover some of the aspects like what is quantum algorithm, then components of quantum algorithm, then the elementary quantum algorithm, which actually have no use in practical field, or the use is not very significant. Then we'll talk about very elementary algorithm like Deutsch algorithm. Then we'll talk about the extended version of Deutsch algorithm, that is Deutsch algorithm. Then we'll implement Deutsch algorithm on Qiskit. Then we'll conclude our lecture. So quantum algorithm is an algorithm which runs on a realistic quantum computation. That means the model that can be implemented realistically. So gate model quantum computer is one of them. The essential feature of quantum computation is superposition and entanglement. As I said earlier, that superposition puts multiple level within a single state, and entanglement provides an impact on measurement of two different particles, which actually bring together at first and let them interacted. So this interaction make them as a single entity. This superposition entanglement provides us a parallel operation, and that is an advantageous operation over classical computers, and that is why we get computational speed up with lower resources. The algorithm that solves some problem is known as decision problem, triviality finding existing problem more efficiently than classical computers. The key components of quantum algorithm are qubit, then oracle, then we have quantum gates, then we'll have to measure our output or outcome, so we need measuring device. The most elementary quantum algorithms that have no significant impact on the fields, but still it shows that quantum computer is much faster than classical computer. These algorithms are Deutsch algorithm, the extended version of Deutsch algorithm, Deutsch algorithm, then Berson-Wasserian algorithm, then an artificial algorithm built by Simon. So it is known as Simon's algorithm. Now let's talk about Deutsch algorithm. David Deutsch first proposed it. It can find an unknown function with less number of queries. So what happens is classically we need at least 2 queries, but quantumly we need only 1 query. What we do in operation is we give input 0 and 1, we find output 0 and 1, but this 0 and 1 provides about the characteristics of function. So when the function is constant, whatever input we provide will get either 0 or 1. But if the function is balanced, for different input we'll get different output. It's like if I put f of 0 and we get 1, so for f of 1 we must be getting 0. This is Deutsch algorithm circuit. Then we have 0 and 1 as input. We provide Hadamard gate on and after applying Hadamard gate on them, then we apply oracle, then we apply Hadamard on first qubit, then measure our first register, we'll get output, and when we get output we'll be able to find out whether it is constant or a balanced function. Deutsch algorithm is extended version of Deutsch algorithm. We provide input more than 1, that means n number of input, more than 2, that means n number of input. Then we get output also similar kind, and from that we can find out whether the function is constant or balance. If all output is 0, then we know that for certain that our function is constant, otherwise the function is balanced. In classical computation, we need at least n by 2 plus one number of trials, but in quantum computation we need only one shot. That means the complexity is reduced to order of 1. Now we implement Dojos algorithm with Qiskit. First we need to theoretically understand what actually happens when we apply Dojos algorithm. So when we apply Dojos algorithm, and if the function is constant, then nothing actually happens, and the input is equals to output. So whatever I send it input will get the same thing as output. So this is like applying a I function on qubit. So in Oracle we actually apply I for constant function, but for balance function we use CC0 because we need other type of output from our circuit. So let's see in Qiskit what actually we get. So as I said in the previous lecture, that we first import everything from Qiskit, then we plot our circuit, then we'll get our result in histogram. So we draw our circuit, we apply all kind of gate according to our requirement, and after that we get the circuit diagram. Here we apply a function which is for balanced function or balanced Oracle. If we need a constant function, then we wouldn't use this. So for balanced function we apply C0 in the Oracle, and as I said earlier that this Oracle will give us other than 0 value. So here we get other than 0 value with 100% of probability. So whatever we say as theoretically, we can verify it with practical implementation. So that is what we can achieve from practical application of Qiskit. So from this we find some information about quantum algorithm. We also find out what is the basic quantum algorithms, and we learned about a simple algorithm and the extended version of it. Then we implement it. In the next lectures we'll be able to check out the more complex algorithm, and based on that we'll be able to learn quantum computing, and we'll be able to understand more complex theories and computations. So thank you very much for your time. Hope to see you next time.